So this is practical number 9 here. Analysis of 2 cube and 2 square factorial experiments in RBD. So we'll consider first example as below is given the plan and yield of 2 square factorial experiment involving two factors n and s, each at two levels 0 and 1. Analyze the design. So we are having this data for this 6 blocks. We are having 1, 2, 3, 4, 5 and 6 blocks, and the treatment combinations we are having 1, S, N and NS. Likewise here everywhere we are having this as the data here. So what we do here while doing this analysis, total of yields from different blocks. So blocks we have written here 1, 2, 3, 4, 5, 6 here, and related to treatment combination 1 in block 1, what is the value? That is 117 that we have taken there, this value here 117. Then in block 2 related to this 1, what is the value here? That is 120. So that value we have taken from this and we have written here. Such a way we have taken all these values for all the remaining blocks, and for the remaining treatment combinations also we have collected the values from the given data here. Okay, then what we have done, we have taken total of this all 6 values, that is this value we are having. Similarly here also we have taken total, this one is also total of this all these 6 values, this is also total of all the 6 values. This way we have obtained the totals for all the treatment combinations from all the replicates or blocks here. Okay, and here just see this is the total of block here, block 1 total here 472. Either you can obtain from this or you can take directly from this also, you will get the same answer because the same observations we are having here, only we have arranged according to our treatment combinations here. So we'll get this as the block totals here, all these 6 blocks we are having, so 6 totals will get, and total of this all these 6 values will get this one, or total of all these treatment combination, that is this one, that is the G here, grand total. Then we require this for obtaining block sum of square, we require square of this block total. So squares we have done here for this, this is the square of 472, this is square of 485, likewise here, and this is total of all these squared values here. Then nextly what we do here, we'll prepare the yards table. Yards table is prepared. In the first column we write treatment combination, second column total from all replicates, means this value here, this one, these 4 values that we have taken because we are having 4 treatment combinations here. So those values we have taken here. Just see, when we are writing this treatment combinations here, we have to follow the order. While writing this treatment combination, remember here, start with 1 always. Then take the one of the factor here. This is first factor we have taken, n, second factor as s. Then multiply this n with s, that we are getting as ns here. Such a way we are having, this is the way to write the table here, treatment combination, then only we will get the required sums what we want to find. If you change the order here, you are not getting the required answer which we want to find out. So totals we have taken here. Then how we are preparing yards table? In the next column what we do, we add the first 2 values, that is this value, next 2 values we add here, and that is this value. Then this is the first half. First half we prepare by adding the pairs here, first, second, third, fourth, likewise. And in the second half what we do the subtraction here. So how to do subtraction? Subtract the first value from the second value, that is 802 minus 610, that is this value. Similarly from the fourth value subtract the third value, that is this 57, and similarly do the same thing over here in column number 4. So whatever value we are getting, this first value, that is total of this grand total G here, actually this value is grand total here. This is the value, that is the subtract, this is addition of these two values, that we are having this value here, and this minus 29, how we are getting this minus this, we are having this minus 29, this minus this, we are having this value here. So we have written here, this is grand total G here, this is the related to N, we are having this value here, square bracketed N value here, and this is S here, the 29 here, and ns we are having this here. And how to get the sum of squares here? So what we do here, bracket square means whatever the factor we are having, it's square divided by the total number of observations. How many observations we are having here? Here 6 blocks and 4 combinations, so 6 4s are 24 observations we are having. So because of that, its divisor we are having 24 here. So this first value is G here, J square by 24 means total number of observation, that is our CF, actually this value is CF. Then N square divided by 24 means this square divided by 24, we are having this value. Similarly 29 square minus 29 square, it becomes positive, divided by 24, it gives us this value. Similarly 135 square divided by 24, this gives this value. So we got this sum of squares from this here. Then we'll go to the next part. We obtain the remaining sum of squares here, different sum of squares. In that, firstly we obtain the total sum of squares. Previously we have obtained so many times this total sum of squares. So how to obtain that? Double summation xij square minus ct, correction term here, or it may be called as correction factor CF also. We can write anything here, ct or CF here. Double summation xij square, how we are doing this double summation xij square? We are having this values as the xij values, this 24 values we are having. So how to get this double summation xij square? Square this value plus square this value plus square the value, square this value, total all this 24 values, square each and every value and take its addition, that is the double summation xij square here, and that value is this value here, and minus correction term that we are having here in the previous table, that is this value here, or correction factor CF we are having, that we have substituted here. After taking subtraction, we will get this as the total sum of square, TSS we are writing here, or you can write TOSS also. Block sum of squares can be obtained summation of bj square upon 4 minus ct here. Why this is divisor is 4 here? Because while obtaining this block totals, what we have done, we have added the 4 values here. See this block total, when we have obtained this total, we have added this 4 values. So because of that, that divisor we are having as 4 there. So how we are getting that value? Summation bj square means this value we are having divided by 4. See that value copied here, divided by 4 minus CF, and that is this value, or CT is this value. Take the division and subtraction, will get this value. Then treatment sum of square will get Sn square plus Ss square plus Sns square. These 3 treatment combinations we are having, Ns and Ns. Related sum of squares, if we add, means this we are having in the table here, this 3 values. If we add those sum of squares, we will get the treatment sum of square, that is this one here. Then error sum of square can be obtained by subtraction, total sum of square minus block sum of square minus treatment sum of square, that gives us here error sum of squares. So we'll go for ANOVA table here. Source of variation, degrees of freedom here in the second column, sum of squares, mean sum of squares, F ratio, F table here. So sources of variations are blocks, treatments, NS, NS. These are the actual treatments here. Okay, 4 treatment combinations. So because of that, we are having 3 degrees of freedom here. 6 blocks. So we get the degrees of freedom related to block as 5. 6 minus 1 is 5. And this 3 what we are having, that we have divided in this separate one, 1, 1 and 1 like this here. So addition of this 3 is nothing but this one we are having, and addition of this 3 sums, that is the sum of square due to treatment. But we are not collectively, we are not interested, we are interested in the separate treatment combinations. So we have taken separate values over here. Error degrees of freedom we get by subtraction here. So we get here 23, 24 minus 1 we are having 23 here, 23 minus this 5 minus 3 here. So 23 minus 8 we are having 15 here. So such a way we get this as 15 value here, or you can have this as b into r minus 1 here. Sorry. Okay, you will get that way. This is by subtraction we are having error degrees of freedom. We have substituted here this sum of square, what we are having 1208 related treatment sum of squares here, also here. Everywhere we have substituted these values. This we have obtained here only. Same values we have substituted in the table here itself. And then in the next column we obtain mean sum of squares, that can be obtained. Sum of square divided by degrees of freedom. So this divided by this we are having this value. This divided by 111, so we'll get as it is here, and error sum of square divided by its degrees of freedom 15 here, that is this value here. So after getting these values we find out f ratio here. How to get f ratio here? This mean sum of square due to that factor divided by mean sum of square due to error. So this divided by this value 176.0972, we are having this value. Similarly this divided by this one here, so we are getting this value 35.04 divided by this. See here in the numerator we are having less value than the denominator. So what we do in that case, we take 1 upon f here. So 1 upon f means we take the error mean sum of square in numerator, and this we take in denominator. So 1 by f we are getting as this value here. So we have done this 1 by f here. So what we do for obtaining table value, will change the degrees of freedom over there. So because of that this value is different than this two here. Okay, and this we are having the straight way here, this divided by this, that is this value we are having. Only what we are having here 1 of 1 f we have done. So because of that degrees of freedom changed here, and we are having this value related to that 15 and 1 here. This is 115 f with 115 f 115, and this is f 15 1, and this is f 515. This value is f at 515 and 0.0 level of significance. Same values I have written here. F 515 is this, f 4 115 is this, and f 15 1 is this value, and same values we have substituted in the table. So from table we can take here a decision. Just say this is less than this, so blocks, they do not differ significantly here, they get accepted. That hypothesis of blocks differ significantly, that gets accepted here. This with this, if we compare, only this gets rejected here. This is also accepted, this is also accepted. Just see here, only the factor n gets rejected, otherwise all gets accepted from this. So what we are having here, h naught b, b for block I have taken here, b1 b2 b3, b1 equal to b2 equal to b6 equal to 0 here, and in h1b its alternative we are having blocks differ significantly. This means blocks do not differ significantly, here they differ significantly. F statistic we obtain MSB upon MSC following f 515, and we are having this value as f here, and f table we are having this value. So f calculated is less than f table here, so we accept h naught at 5% level of significance, that is blocks do not differ significantly here. Same we do this for the different factors here. We write firstly hypothesis, and then we take the decision accordingly what the f value. Testing of hypothesis for significance of test treatments here, the test statistic for different treatments, and the hypothesis also we are having here. So h naught we have written h naught n, that is n equal to 0, h naught s equal to 0, h naught ns equal to 0, and their corresponding f statistics we are having here. And we take decision, only n gets rejected and otherwise all gets accepted here. So we are having here decision rule is this one here. So conclusion, we are writing all factorial effects are insignificant except n, that is n is not equal to 0 here, that we have seen in the table also. This is gets rejected only. Therefore factorial effect s and ns are insignificant and n is the significant here. So this completes the first example. We'll go for the second example. In example 2, we are having this analyze the following 2 cube design. So for 2 cube design, we are having this 4 blocks here, and corresponding all the combinations of this 2 cube we are having as 8 treatment combinations we are having for those 2 cube is equal to 8. So we are getting 8 treatment combinations, and for related data we are having here for in the 4 blocks. So once again the same procedure we repeat for what we have done for 2 square. What we have done here, these are the blocks here 1 2 3 4, and treatment combinations we have written. Once again follow the order here. Starting treatment combination is 1, then factors a b here, then a and b we have written here. So we take multiplication of this ab, so that multiplication of ab is c, ab is a into b here. Okay, so we get next treatment combination as AB, then introduce C here. Introduction of C we have done here. Then we get C into A, it gives us AC here. Next combination we have to write such a way. C into A is AC here. Then C into B, it is BC, and C into AB we are getting ABC. Such a way you have to follow the order of writing this Yates table. While preparing the Yates table, we have to write this way. The totals I have written in the same manner, and same I have pasted over there to get the Yates table. Totals we are obtaining first here, total yields from all the different blocks. See here in block number 1 related to 1, what is the value that we will see here? In block number 1 related to 1, we are having 38.5. Here 35.5, and here 32.9, here 46.3. All those values we put here. Just see all those 4 values we are having pasted here. Total we have taken of this. Similarly for all the treatment combination, we take the values from the given example and we'll write here and take the total of those values over here. Then after that what we do, we take total of this here. Only we have shuffled these values. These values are from block 1 itself. So we take total of this, that is the total of block 1 here. So we have written here block 1 2 3 4 here. Its total means total of all these 8 observations. We are having this one. Similarly we are having this 8 totals here, and their squares we are having here. How we are having square of this we have written here, square of this like this, and some of these squares that we are having here, this value. Okay, this is the sum of squares here, squares of the block totals. Then we go for the Yates table. Once again I told you the treatment combinations how to write in Yates table. 1 AB multiplication of AB, then introduce the next factor, that is C, then AC, take the combination of this previous one with this new introduced factor, AC, BC is this one, and AB with C, that is ABC, and write those total yields from all the replicates, that is this values we have taken here. Okay, so we got this one here. Then once again follow the same procedure for making the Yates table. In the first half we take pairwise addition of first second, that is this value, addition of third fourth, that is the second value, 5 and 6th value, 5th and 6th value, that is this third value, and 7th and 8th value, that is the 4th value. We do this as the addition, and in the next half what we do, we do the subtraction over there. How do we subtract? From the next value we subtract the previous value, means from second we subtract first one, from fourth we subtract third one, like this. Likewise we are getting this value. Same procedure is repeated for this column also and for this column here also. See, when we are having 2 square, then we are preparing here this 2 times we are doing this. We are getting 3 and 4 columns only. Okay, but here 2 cube we are having, so we prepare this same procedure we repeat for 3 columns here. This is the first column we have repeated and we got this one. For this column we repeat the procedure, we get this one, and once again for this obtained column we repeat the procedure, we get this one, and this is the final column we are having, and this value is nothing but G here, grand total. Whatever you get related to treatment combination 1 value, that is the grand total. You have to remember how many columns you have to prepare. 2 raised to 2 is there, you have to prepare this 2 columns there. 2 cube is there, you will have to prepare this procedure. That procedure of addition and subtraction you have to repeat that many times. Okay, so here 2 cube, so we have repeated this procedure 3 times here. First value is G and corresponding treatment combinations we are having, so we are having this bracketed values of this here. Actually sums we are having this related to A, this value we are having this here. Okay, then what we do here, bracket square divided by 32 here. Why here 32? Because we are having 4 blocks or 4 replicates there, and each replicate having 8 observations, 8 treatment combinations. So 8 into 4, 32 observations we are having total, so we divide it by 32. So G square upon 32 means this square divided by 32, we are having this value. This square divided by 32, we are getting the sum of square related to A, and such a way we do all this columns, all these values we prepare here, this remaining values, square of this value divided by 32 everywhere we have done. And then after that we obtain the total sum of squares firstly, and then we go for the ANOVA table after getting all the sums here. So total sum of square, once again the same procedure, double summation xij square minus ct. So how to get double summation xij square? Once again this original values we are having here, square each and every observation, means this square plus all these squares, 32 values, square each and every observation here, take its sum, that is nothing but here double summation xij square, and that value is this one here. Correction term we are having, we got this term here in the table 49117.61. So that value we have taken here. Take subtraction, we get this as the total sum of squares. Block sum of squares, while obtaining this summation of bj square upon 8 here. So bj square we are having here this one here, actual this value is block 1, its total we are having, its square we are having, and every time we have done block 2 total, its square, block 3 total, its square, block 4 total is this value, its square we are having, and its sum we are having, that is bj square. And while obtaining these totals we have used here 8 observations, so because of that we are having this divisor as 8 here. Remember such a way, so you are not getting confused over there which factor to take in denominator. So divided by 8 here and minus ct here. So what value we are having, that substituted here, divided by 8 minus ct is the same value here, we'll get this one here. Then treatment sum of square is addition of all these treatment combination, its sum of squares that we are having, means this value, I'll show you in the table, this value, sum of this all these values, this remaining 7 values, its sum is nothing but the treatment sum of squares that we are having as this one, sa square plus sb square plus sab square. Then how to get error sum of square? Error sum of square is total sum of square minus block sum of square minus treatment sum of square. So total sum of square is this value minus block sum of square is this value and treatment sum of square is this value. So subtract that, we'll get this as the error sum of square. Then after that we'll go for analysis of variance table. Then while writing this source of variation, you can change here order. Anyway you can write here, only while writing this values remember which value we are writing here, that you have to only remember here which value you are writing here. I have taken the same order what we are having in the Yates table here. This should be treatment, R it should be. Okay, so this is blocks, 4 blocks, so degrees of freedom we are having 3 here. Treatment combinations we are having 8, so because of that 8 minus 1 we are having 7, and 7 combinations we are getting, so individual 1 degrees of freedom we are having here. Error degrees of freedom will get by subtraction here. Total 32 observations, so degrees of freedom is 31 here. 31 minus this 7 and 3, that is 10, so it gives us 21, so error degrees of freedom is 21 here. Block sum of square just now we have obtained in the previous slide, that is 228.5509, so that value substituted here, and this specific treatment sum of square, that also we have obtained, that we have substituted here. Error sum of square just now we have obtained 305.9315, that we have written here, and this is the total sum of square, that is also here, so that this value we have substituted over here. And then we obtain the next column, we prepare mean sum of squares. How we are getting this mean sum of square? Sum of squares divided by its degrees of freedom. So how we get this value? This divided by 3 here, and this divided by this means we are getting the same values over here for all the treatment combinations. So we are because we are dividing it by 1 here. Only this 305 divided by 21, it gives us 14.5681 here. Then after doing this mean sum of square, we go for F ratio here. How to get F ratio? Corresponding mean sum of square divided by error mean sum of square. So this divided by 14.5681, that is this value. Then next we are having 17.8503 divided by this, we are having this value. See this two observation, they are less than this one here. So what we do? We do here 1 upon F, means this divided by this value. We are getting in both the cases 23.0213 here. This is larger than this, so we'll take our usual F ratio. We are getting 5 point here. This is less than this mean error sum of square, so we'll take once again 1 upon F here, that gives us 16 point this. Here we are having once again less than this here, here also less than, so 1 upon F taken in both the cases, we will get this values here. So wherever 1 upon F is taken, I have taken the degrees of freedom for F table also get interchanged there. Here we require 121, but for this where we have changed that 1 upon F, so for those we are having F21 and 1 here, degrees of freedom we are having, those parameters are 21 comma 1 here at 5% level of significance. This values I have written here. 4.32 is for 121 F 1 comma 21. For this we are having this value 4.32. Only two values we are having here, and other values are 1 upon F here. So this value is F for 3 and 21. This 3.0107. Okay, then compare this with this here. Here in this case block gets rejected here because this is larger than this one. So block sum of square, block F ratio related to block is larger than, calculated F is larger than this F table. So blocks do not differ significantly, that gets rejected here. This hypothesis gets rejected here. Here this gets accepted. This one related to factor C, this gets rejected only. Others are accepted here. Related to C gets only rejected here, and this blocks gets rejected. So we'll write their conclusion over here. I have written those values, F related to F table values here. H not B, we are having B1 equal to B2 equal to B3 equal to B4 equal to 0 here. H1B, its alternative we are writing, blocks differ significantly here. Test statistic we are getting here, F calculated greater than F 321, this is 3.07, and here 5.229. So we reject H naught at 5% level of significance, that is blocks differ significantly here. Then testing of hypothesis for significance of treatment. The test statistic for different treatments is, statistics we have written here, test statistic is this value here, and these are the hypothesis we have written, H naught A equal to 0, H naught B equal to 0. Likewise all these hypotheses we are having, and here FA SS square upon MSE, we have obtained this in the table itself there. So this value we are having, and only C gets rejected related to C. So we'll write here, this is our decision rule, usual decision rule. So what we conclude from this, all factorial effects are insignificant. except C, that is C is not equal to 0 here, because all the hypotheses they get accepted, only related to C it is rejected here. Therefore factorial effects AB, AC, BC, ABC are insignificant and C is significant here. This is the third example you are having. This only you have to complete here. Well, what you have to remember here? Only here 3 replication means 3 blocks you are having here. So 3 into 8, 24 observations you are having here. You have to perform here 2 cube experiment here. This one is 2 cube experiment. Only what you have to do here? Only change you will get over there here. That divisor you are having, divisor we are having 32 there, because 4 blocks we are having here, 3 blocks or 3 replicates. Block is nothing but replicate. So what we are having here, 24 observations, 8 3 are 24 observations we are having. So only that change you have to do here, and same procedure you have to repeat for this third example here. Thank you.